I use the SDRconsole software for my QO100 station and SmartSDR for my FlexRadio. Both have in common that they run on a PC. I like such programs because they work with a mouse. With one exception, I want a PTT, preferably a foot switch, to keep my hands free. I had to search and experiment till I found out how it works. I want to save you this time and share my learnings. No worries, it will be a short video. Hello wireless enthusiasts. Here is the channel with a strange Swiss distortion in the signal with a new video around wireless and other exciting stuff. Remember to subscribe if you do not want to miss the following emissions. The first question is, where can we connect a PTT switch to our PC? And the second, where do we get the switch from? Modern PCs do not have digital inputs anymore. So these SDR programs use a trick. They use an ancient serial port. But they do not use the serial data lines because simple switches do not support that. So how does this work? Let's quickly step back in time to when serial communication was a thing. The most famous standard for PCs was RS-232, introduced in the 1960s. It was used to connect printers and modems to PCs, for example. It was omnipresent in old PCs, but was replaced by USB connectors in newer models. The original standard used ±12 volts for signaling. This was replaced by normal TTL levels of 0 and 5 volts for PC usage. Each port has a TX and RX pin where data is transferred. To synchronize the communication, they used so-called handshake signals. And this is the trick we can use to get a few digital in and outputs on modern PCs. We use a so-called USB to serial adapter that offers some or all handshake lines. Like that, PC programs get a few I/O pins. So let's look closer at the different RS-232 signals. For our project, we can remove a few of the non-relevant pins. Next, we have to find the input pins, because the programs want to read the status of the foot switch. As we saw before, our PC is the data terminal equipment. We filter the output pins and ready is our result. DCD, DSR, RI and CTS are input pins. Cool! Because some of the pins work with inverse logic, on is low or 0 volts for those pins. Now let's check the software. In the SDRconsole, we go to Transmit Options PTT. Here we can select a COM port and the CTS and DSR signals. As expected, both are input pins. Let's have a look at the FlexRadio. Here we have to enable PTT in the CAD software, where we have to add a new interface. If we select Serial and Existing, we can select a COM port and two signals, RTS and DTR. Strange. These are clearly marked as out in our table. Anyway, we hope these guys from Flex have a plan. Next, we have to find a USB to serial adapter that exposes these pins. Here we have two possibilities. Number 1, a cheap board without case. Number 2, a serial cable or adapter with a DB9 connector. Number 2 always exposes the needed pins because they belong to the standard. For number 1, you have to check before hitting the order button. I enclose some product links in the description for your comfort. Now we need a foot switch. You find plenty of cheap and reliable switches on the usual platforms, so you can decide which one you choose. Now comes the last question. How to connect the switches to the adapter pins. To check if your adapter works and check its pinout, you can download RealTerm, insert your adapter, select its port and press Change. The baud rate does not matter because we only use the handshake pins. If you connect one of the input pins to ground, the respective indicator should light up. For the SDR console, the connection is simple. We connect the switch between either CTS or DSR and ground. In the software, we select the port and the pin accordingly. Done. The Flex is not as simple, and it took me quite a while to find out how it works. Remember, in their software you can only choose output pins. Fortunately, I found a write-up of mic VA3MV. They seem to loop back the handshake signals. So our switch has to connect either RTS to CTS or DTR to DSR to key the transmitter. And we have to input the connected pins in the CAT interface. Select also active low, and ready is the flex pedal. If you choose interface number 2, you must connect a DB9 connector to your pedal. If you choose interface number 1, we have to solder a shielded audio cable to the respective pins on the board. And if you want it nice and clean, print a 3D box. I leave a link to my STL files in the description. And the cherry on the cake is a blob of hot glue to create some strain relief to the cable. I use both pedals in parallel on the same PC. Because they use different COM ports, this is no problem. Use a USB hub if you do not have enough USB connectors on your PC. Maybe you comment if you use a different method or if you use a PTT with other PC software. That's all for today. As always, you find all the relevant links in the description. 73 to everybody. Please consider supporting the channel using the links in the description. See you in the next episode.